All right, in order to prepare for the chapter test on Monday, you want to make sure you know the key pieces of information. Vertex form is y equals a, x minus h squared plus k. The vertex is h comma k. The a value represents stretch, compress, or reflect, depending on what its value is. So it's stretched if a is greater than 1. It's compressed if a is between 0 and 1. And it's reflected if a is negative. Standard form is y equals a x squared plus bx plus c. The vertex in this form comes from negative b divided by 2a, and then plugging that value back in to find the y value. We have three types of factoring. We have grouping, which you use if there are 4 terms. We have our special formulas. So that's difference of squares, which is a squared minus b squared, which factors as a minus b, a plus b. And then we have a perfect square trinomial, which is a squared plus 2ab or minus 2ab and always plus b squared. And it will always factor as a minus a plus b quantity squared. And then our final technique is just factoring if the a value is equal to 1 or a is greater than 1. And then we have methods for solving. So if you're solving by factoring, you're going to take the factored form and set it equal to 0. And then you're going to set each factor equal to 0 using the zero product property, and you'll solve for x. We have completing the square. So that's where you have ax squared plus bx plus c. And then you want to complete your square. So you get ax squared plus bx plus b divided by 2 squared equals negative c plus b divided by 2 squared. And that factors as x plus or minus b divided by 2 squared equal to that value over there. And this only works if a is equal to 1. If a is anything greater than 1 or less than 1, you have to divide it out. We also have the quadratic formula, which is made up of the discriminant. The discriminant does not include the radical, so it is just b squared minus 4ac. And if you get a discriminant value that is positive, you get 2 reals. If you get a discriminant value that is 0, you get 1 real. And if you get a discriminant value that is negative, you get 2 imaginary. Quadratic formula says x equals negative b plus or minus the square root of the discriminant, which is b squared minus 4ac, all over quantity 2a. So that takes us through how to solve. It takes us through our forms. The last part of chapter 5 was complex numbers. So that's your powers of I. you have I squared, I cubed, I to the fourth. I is equal to the square root of negative 1. So anytime you have a square root of negative 1, you're going to turn it to an I. Once you are in the cycles of I, if you get I squared, that's actually negative 1. I cubed is really negative I, and I to the fourth is positive 1. So another technique we have is solving by taking the square root. That works if the values are real or imaginary. So an example of that would be 3x squared plus 27 equals 0. So if you're missing the bx term, you would say 3x squared equals negative 27. Divide both sides by 3, and you have x squared equals negative 9. So I know that this is equal to a negative, so my answer is imaginary, and you get plus or minus the square root of negative 9, which becomes plus or minus 3i. You have to remember that anytime you have something squared, you get a plus or a minus. So that's an example of simplifying a complex number and getting your answers. The last thing with simplifying or complex that I recall having some issues with is rationalizing that denominator. So that would be like if you had 17 plus I over 3I minus 1. That is really the same as 17 plus I over negative 1 plus 3I. And to rationalize the denominator, you only multiply by the reciprocal of the imaginary. So you're going to multiply top and bottom by negative 1 minus 3I. And then you FOIL that, so you get negative 17 for first, and then negative 3 times 17 for your outer. So you get negative 51I minus I. Positive times a negative gives a negative 3I squared, all over negative 1 times negative 1 is 1. And then positive 3i, negative 3i, negative 9i squared. So the middle terms cancel in your denominator. Up here you group those together. And then a negative I squared, well I squared is like negative 1. So that's like multiplying by negative 1 to both of those. So that becomes a positive 3, and on bottom it becomes a positive 9. So you get negative 17 plus 3. So you get negative 14 minus 52I all over 10. So that pretty much wraps up everything we are looking at in terms of Chapter 5. I am posting the answer key to the Chapter 5 textbook study guide and review, so you can go through, do any of those practice problems, look at their examples, and check your work.